regarding building your research profile, and this will be useful for anyone who is planning to add publications to their profile, and in particular to students who want to build their research profile for fall 2025. So we are Team Videsh, and our main aim is to help you land your dream university. So we are very active on LinkedIn, but for those of us who have not, for those of you who do not know about us or who are attending this webinar for the first time, let me introduce our team. So my name is Raj. Here is my twin brother Rajat, and our very close friend for the past 10 years, Shridat. So we all graduated from IIT Madras in 2017 and 2018, and then we applied to grad school. When we applied during that time, we got admits at MIT, Stanford, Purdue, Berkeley, UIUC, ETH Zurich, etc. And then me and Sridhar decided to go to MIT for our PhD, and Rajat completed his PhD from Purdue. During our PhD experience, we really inculcated the importance of doing research. We realized that in the undergraduate, research is not valued at all, but it's that one skill which is so useful and so relevant for many of the things which we do in graduate life and even in industrial life as well. So in all of our webinars, we really give a tremendous emphasis and importance on doing research. And this webinar is directed towards research and how you can start building your profile. Here you can see us during our PhD defense, winning awards with respect to research, storytelling, etc. After finishing our PhD, we came back to India in 2022. So now it's been 2 years. And during these 2 years, we have spent a lot of time helping students get to their dream universities. And our vision is to give you a streamlined advice about what it takes to get into the top universities, because we did not receive such advice when we applied. There was a lot of noise out there and we did not receive proper guidance. This webinar, or this workshop rather, is an attempt to provide you this kind of a streamlined guidance, so that you are aware of what it takes to get into the top universities, and why research is valuable so much. When I joined MIT, I saw that everyone around me, all the students who had been admitted, really had a very strong research profile. So in today's agenda, we will be covering a lot of things. We have divided it into three parts broadly. I will be going into the research profile basics up till the paper outline stage. Then Rajat will cover part 6 to part 12, which is writing about the middle part of the paper. And then Shridat will cover the last part, which is finishing the entire manuscript, submitting to the journal. And then Shridat will also talk about our long-term mentorship program. So let's get started. In my part, I will cover 5 portions. And we will now get started with the first portion, that what exactly is a research profile? Why should we care about it? And why are we having this webinar in the first place? So you all must be thinking that why is research profile so important for grad school applications? And in case some of you in this call do not know about this, research profile is one of the biggest factors for getting good admits. And we did not know this at the time which we applied, but now the three of us are really very firm in this belief that if you want admits to a good university, you really need a very strong research profile. And we have seen this after 5 to 6 years of PhD experience, after coming back to India, and also looking at many different application profiles. So the question is, why is research profile so important for grad school admissions? And why do admission committee really give this much importance? So if you look at this figure over here, there are 5 sub-figures. There is the invention of the DNA structure, chat GPT invention, imaging of the black hole for the first time. This image right here shows high speed photography when it was discovered. And here there is a book called Thinking Fast and Slow, which the some of the works in this book got the Nobel Prize in economics for Daniel Kahneman. So I want you to look at these breakthroughs and think, who is behind this breakthrough? Who made these breakthroughs possible? So behind all of these breakthroughs, there is usually a researcher or a team of researchers. For example, look at this particular researcher over here. There is a black hole image which has been discovered and which she has seen on her laptop. And this was the first time the black hole image was seen by anyone in the world. Now, when this researcher makes this discovery, who is it or who is it benefiting? It's of course benefiting the researcher, it's benefiting the scientific community, but it's also benefiting the university, because the university reputation is directly linked to the research output which the university is producing. So when you apply to a grad school, the university is betting on the fact that you will become a researcher like this. And if you have a strong research profile, that's your way of convincing the university that you can uh, become a researcher like this. And that's the reason the research profile is valued so much. It's the strongest way you can convince the admissions committee that you have the potential to do very good research, which in turn is good for the university as well. Now, when you think of research profile, many students are quite confused about what exactly is meant by a strong research profile. So let's start from left to right in this slide, which is there on the screen right now. I'm going to start with research projects. Now, everyone has projects on their profile, and it's very easy to do projects. You can just look at a GitHub repository and then just download it or clone it, run those results, and that will be a project on your profile. That's why projects are very low value, since everyone has projects. If you move on the right hand side, if you have done research internships with a professor from your college or international research internships, they are more valuable, because that way you can get a letter of recommendation from the professor. It might even lead to some report or some publication. But the most valuable things in the research profile are the three things which have been mentioned on the rightmost of the screen here. The most valuables are journal paper, conference presentations, and patents. These research outcomes have the highest value in a research profile. So if you are a student right now who is planning to apply for fall 25 next year, or if you are planning to apply for grad school anytime, remember that having projects is not enough. You should really aim for getting these three things on the right hand side over here: papers, conferences, or patents. And although December is 6 months away right now, we still can get papers or conference presentations, and we'll show you how in today's workshop or webinar. So it's not too late to start working on building your research profile. Okay. Now, when I want to zoom in on the first aspect here, which is titled papers. When you think of papers, the papers itself consists of three types. So when you think of papers, there can be either journal papers with new results, and this takes a long time to publish. But there are two other things which also count as papers: literature review papers and preprints. And these are relatively easier to publish. So if you are planning for next year, and if you have 5 to 6 months to build your research profile, you should definitely aim to have literature review papers or preprints. On the other hand, if you are planning to apply 2 years down the line, then you should aim to have journal papers with new results. One more thing which I want to mention here is that on the screen you can see my resume when I applied to grad school, and I'm just zooming in over here to show you that my paper was not published when I applied. It was under preparation. So your paper might be under preparation or it just submitted. You can mention it over here, like you can see I have mentioned in italics. You don't necessarily need to have the paper published for you to mention it in the resume. You can write something like this, and that is completely fine. You can then have a PDF of the paper in your portfolio website, so that it adds a layer of verification. And the professor with which you have worked, they can also give you a letter of recommendation, which adds as another layer of verification. Okay. And so please keep in mind that you do not necessarily have to publish. So this is the first part in which we described that research papers have the most value. And among research papers, there are three things: journal papers, literature review papers, and preprints. Now, let me come to the part two of this, my section, which is research paper basics. So first of all, if there are participants in this call who have never written a research paper before, you might be thinking that I am very new to research. Do I have what it takes to write a paper? The first thing I want you to know is that have belief in yourself, because research paper writing is a skill which can be learned. Secondly, the first paper which you write will not be the best paper you will write, but getting the manuscript finished is amazing. And the third thing which I want to let you know is that having the first paper does not necessarily always take 1 year or 2 years. Even within a period of 3 to 4 months, you can have a good enough literature review paper. What I mean by literature review paper is take a topic and summarize what other people have done on that topic. And that itself can be a very nice literature review paper. So remember that papers can get rejected and sometimes it may take a long time to publish, but you have to be patient in this process. If you work hard and follow the steps which we are going to teach you today, it is possible for even you to write a paper. So first thing is that the first takeaway from this webinar you should have is that if you are doubting your ability to start doing research, just get started with it. And don't think that am I meant to do research, etc. Everyone can learn this skill. Okay. The second thing, when you start writing any type of a research paper, let's say you are writing a literature review paper, okay, and the topic is, let's say, some topic related to machine learning. The first task is to read a bunch of papers and to summarize them, right? And then you will write about what people have done in this field, what are the areas of further improvement, etc. Now, the first part, which is reading other papers or reading other research papers, is one of the toughest things which we have observed. And this is the part where students get stuck a lot. Because when you read a 15-page research paper, sometimes you get bored, sometimes there is too much math, sometimes you find it hard to follow, and then you just leave it. Please do not leave the paper while reading it. Remember that there are always two modes of reading a paper. The first is an in-depth mode, and the second is a bird's eye view mode. Let me take an example paper and actually show you what this means. So, for example, let's say if you come across this paper, which is machine learning aided uh, COVID-19 prediction. This was the paper which I wrote. Let's say you are planning to read this paper and you see that, oh, it is 17 pages. How do I read it? The first way to read it is the in-depth mode, where you go through different sections, you make notes about what has been written, and you try to understand every single thing. It may take 2.5 to 3 hours for you in this in-depth mode. And even if you don't understand something, please don't leave it, or please don't leave the paper. Just move ahead to the next section. However, there is a second mode to read papers, which is much easier. That second mode is called as the bird's eye mode. In the bird's eye mode, what you do is just you look at the abstract. That's number one. You look at the figures. You look at the figures and you try to read the caption in the figures. And then you try to understand what this paper has done. And finally, you go to the results and discussion section, which has been written towards the end. So you go to the discussion section and you read the results. That's it. In the bird's eye mode, you just read these 3 or 4 things and you get a brief overview of what has been written in the paper. So if you want to write a summary of the paper, the bird's eye view mode can also be deployed. So initial papers can be read in in-depth mode, but remember that the second mode of bird's eye mode is always available to you for reading and summarizing each paper. The in-depth mode generally takes 3 to 4 hours to read each paper, and the bird's eye view mode takes about 20 to 30 minutes for you to read every paper. And when you are reading papers, right, and when you are summarizing them, try to maintain an Excel sheet like this, where you may write the paper title, the authors of the paper, and you mention a 5 to 7 sentence summary of what has been written in the paper. So remember again that for a good literature review paper, you have to read at least 50 to 60 papers. So all of them is not needed for you to read in in-depth mode. Many of them can be read in bird's eye mode, and you have to write this 5 to 7 sentence summary. Okay. Now, while reading these papers and while doing the process of research, you will need some tools. The first tool which I want to show you is this tool called Overleaf. Overleaf is a tool which you can use to write research papers. So here you can see in the long-term mentorship program, we are writing papers with so many of these students right now. And Overleaf is the best tool for you to do this. So for example, let me type in one report which I have written in Overleaf. So this is a report which I have written. What Overleaf does is actually it converts everything into a LaTeX format. So for example, if I want to change the topic here to something like Overleaf, Overleaf demonstration for webinar, and then I can click on the recompile, and then you can see that on the right hand side, it automatically translates into this LaTeX type of a format. So once you have summarized multiple papers, and if you want to start writing the different sections of the paper, Overleaf is the best way to do this, because when you see these LaTeX equations appearing on the right hand side, you yourself will feel motivated to keep on writing the rest of the paper. Of course, Microsoft Word can also be used, but I personally really liked Overleaf when I understood this tool. So we will share the link to this. It's overleaf.com. Please explore this for writing paper. The second tool, which is amazing for literature review, is a tool called Litmaps. So this will be found at litmaps.com. So let's say you have read this paper, which I just showed you right now, which is this paper, which is titled Machine Learning Aided Global Diagnostic Tool, and you have written a summary for it. However, the next question which you ask yourself is, how do I choose the next paper to read? How do I find similar papers to this in the literature? And the best way for you to do this is use Litmaps. So you can copy this title, go to litmaps.com and paste this title over here and press enter. Now what Litmaps will do is that it will form a tree. And so here you can see on the right hand side, it forms this tree map. What this tree map shows is that if you look to the left hand side, all these papers are the papers which I cite in my paper. And if you look at the right hand side, all of these are the papers which cite my paper. So then you can click on any of these papers which are related to my paper and which have cited my paper, and then you can read these papers. That's the beauty of lit maps. In one visual tree like this, you can get all the related papers to the current paper. So that way it becomes much easier for you to find which paper to read and which paper to summarize next. It's an amazing tool which I discovered very late in my PhD, but I hope you can use it for finding papers during your literature review. The third tool which I want to talk about is a tool called Mendeley. Mendeley is an amazing tool for documenting research articles and for maintaining references. So for example, here also you can copy paste this article and you can search it over here and you can find this article. You can also use Mendeley to add to your library. So you can create an account and maintain a library of what all papers you have read. And Mendeley also has a desktop app. So it's a great tool for management of papers. So I told you three tools. Overleaf is good for writing papers. Literature review, Litmaps is good for finding papers. And Mendeley is good for managing papers. We will be sharing the links to all these three tools with you. The third part is how to identify the topic for your paper. So all of the students who are in this call, or if you are a working professional, you must be associated with an area of interest. So the first thing to do to identify your topic is first write down your very broad area of interest. It can be machine learning, aerodynamics, material science, economics, sustainability. It can be anything. Just identify your broad area of interest. That's step number one. For me, let's say I take machine learning, and then go one step deeper and try to identify a subtopic in this area. So for example, if you are in material science, maybe you are interested in nanomaterials. If you are in aerodynamics, maybe you are interested in wind turbines. I am going to take scientific machine learning as a specific area which I am interested in within the broad topic of machine learning. So that's the specific topic which I have chosen, correct? And then what you can do is that you can identify papers with respect to this specific topic. So for example, I have chosen scientific machine learning. You can go to googlescholar.com. So that is scholar.google.com, and you can type scientific machine learning. And when you click enter, you will see a bunch of papers. Your first task is to start reading 4 to 5 papers in this field. So once you have identified the specific topic, your first task is to start reading papers in this topic. So the next question would be that how do I choose which papers to read, because there are so many papers? Usually there are two metrics which we choose. First is that you should see when the paper was published, and second, you should see how many citations which the paper has. If the paper has more than 100 citations, it's generally an amazing paper to read. And if it's published after 2016 or after 2017, it means it's a modern paper. A modern paper with 100 plus citations is an amazing paper to read. For example, let's look at this second paper. It has 663 citations, and let me see the year in which it was published. So it was published in 2020. This satisfies both of my metrics. It's a modern paper published after 2018, and it is cited by a huge number of people. So I will definitely read this paper. Similarly, you can identify 5 topics in your specific field, and you can start reading those topics or reading the papers associated with those topics. And remember, as I mentioned, the more citation count a paper has, the better it is for you to read, because if a paper is good, many other papers cite it. Okay, now after you read, let's say 5 to 6 papers in the specific domain, you have to identify a story or a pattern from your initial review, which will ultimately form the main title of your paper. So in my case, let's say I read 5 papers in scientific machine learning, and then I realize that scientific machine learning is revolutionizing so many fields, right? So then I identify the main topic of my literature review as rise of scientific ML. So rise of scientific ML in computing. Let's say I identify this as my topic. So then this becomes my very specific topic, which will be the title, or let me give this as a title. This will be then the title of my review paper. So rise of SciML. This will be the title of my literature review paper. And how I reach this title, rise of SciML in computing. And how I reached this title is I first identified the topic, which is ML. Then I identified the subtopic, which is scientific ML. And then I identified a story. You cannot just stop at the subtopic. You need a story. So my story is the rise of scientific ML in computing. And this will form the title of my review paper. This is how you get started with the title. And then you can read the rest of the papers related to this title. So 5 papers you read to identify the specific story and title. So this is called a specific story, and the remaining 30 to 35 papers you read which are aligned with the specific story. Okay, so there are 3 things. First, identify your domain. For me, it was ML. Identify a subdomain. For me, it was scientific ML. And third, identify your specific story. For me, it was rise of scientific ML in computing domain. You can apply the same framework to whatever field you are in. That will help you select the topic. Finally, once you have selected the topic, and let's say once you have read 30 to 35 papers and summarize them, you have to make an outline of the paper. A nicely written review paper, or any paper rather, has 12 sections in the outline. It has titles, it has author, it has the title, authors, keyword, abstract, introduction, figures, tables, result, discussion, the conclusion section, and then finally it has references and acknowledgement. So even without writing the full paper, first you can start writing the outline. So first you can just mention the title and write your name as the author. It gives you a lot of motivation when you see this in overleaf. The second thing you can do is write a first version of the abstract, which is 200 words. We'll be going into detail for each of this section. Right now, I'm just giving you a broad overview of the different parts of the paper outline. Then you can write a bullet pointed introduction, which is, as you can see, it has been mentioned here. A bullet pointed introduction does not need to be the entire intro, but it has to be just separate paragraphs about what your introduction will look like. So paragraph 1, paragraph 2, etc. And then you can write the references which you will be using in the paper. Remember that once you have the paper outline, right? And if you have the paper outline in overleaf like this, you will get a lot of confidence to continue with the paper. So don't just keep reading the paper and summarizing it. After you have read 25 papers, go to overleaf and write the paper outline. You will get so much confidence and you will get past the writer's block. The writer's block is when you are stuck and when you don't know what to write. Writing the parts of the paper outline will help you overcome the writer's block. Finally, the last part of the paper outline is the figures. Figures form the main story of the paper. So you can also add some figures in the paper outline. And don't worry, the paper outline is just the initial draft. Nothing is going to be final here. It is just to help you get started and for you to overcome the writer's block. So as I mentioned, paper outline is like a skeletal component, which gives you a lot of confidence to advance in the paper writing process. Even when you're stuck somewhere, this paper outline will give you the motivation to move ahead. And slowly and steadily, an outline will help you to conquer the entire paper. Another thing which I want to mention is that when you start writing a paper, you can choose a template. So there are many templates and we'll share those with you. For example, there is one IEEE template, which is a very common template which many researchers use. Here you can see that the template has already created different sections which you just need to fill in. So for example, here there is the introduction, then there are different sections, and then they also have the citations uh, here in the template itself. So you can use the template which will help you get started rather than starting from a blank document. Even Overleaf has templates. For example, this is the template of the Journal of Fluid Mechanics. Here you can write the title. So if my title is Rise of Scientific ML, I can actually edit it over here and then it will appear on the right hand side. So remember to always start with templates because that will make your job very easy of finishing the paper. Okay, now we'll come to the second part where we'll go into detail of each of the things in the paper outline which we mentioned. So in Rajat's section, he will cover the points related to title, abstract, introduction, figures, tables, etc. So I'll stop sharing here and Rajat will take over the next part.
Oh, sorry. I need to make you co-host, right? Okay, okay. Okay, I was able to unmute myself now. Okay. So let me start sharing my screen. Okay, so in this section, we are going to actually look at how to start writing the paper from scratch. If you are new to research, this might be a completely new section for all of you. And it's very important to understand how the paper is exactly structured. I remember when I was starting out doing my research, I was very nervous when I started to write my first paper draft. And I want to show you the first draft which I had written and the kind of feedback that I got from my PhD correspondent at that time. So this was a PhD student working along with me. There was an advisor also, but he was the one working along with me on the draft. So this was the first draft which I have ever written for any journal or any documentation of research which I started in my life. So before that, I had not written any research paper. And you can see the number of markings he has made in my entire document. Um, all the all the text in red is where the PhD student has suggested corrections. So there are a lot of corrections interspersed throughout this entire document, and there are some places where he has even suggested to delete this entire figure. For example, you can see on the right it says delete drawing. So the first draft that you will write will always be something which is more on the mediocre side. It will not be something that you'll be proud of. You think that you have done a good job, but the kind of writing which people are expecting is something completely different. And I got to learn it the hard way. So I want to make this process simple for you by breaking it down into smaller components and to avoid the kind of mistakes I did. So it took me around 10 to 15 revisions of, so this is revision number 2, as you can see. So revision number 1, you can imagine how many corrections there were. I had made blunders and errors in almost all of the sections in my paper, and he had suggested so many changes. You can see this figure is not even clear, it's completely blurred. This is what typically happens. You get so excited by the results that you think that writing is secondary, and you just upload all your plots and figures in the document, and then you just write some text and then you submit. So let us actually go ahead and look at a very step-by-step approach of writing a research paper. So first we'll look at the title and the abstract of the research paper. So the title is the main topic of your paper, and the title depends on the kind of paper that you're writing. So if you're writing a literature review paper, for example, this is an example of a literature review paper which says big data analytics, and you can see in the title itself, the authors have mentioned that it is a literature review paper, which kind of makes sense because there isn't going to be any novel results which they are going to publish in this article, and they are letting their readers know it upfront. They are saying that this is a literature review paper. So this is pretty common. Even in this slide, you can see this paper at the starting, it says a review on polymer nanofibers. So this is the title of a typical review paper. However, if we now look at one of my papers, which is a journal paper, here you can see the title describes the main topic of the paper. So in this case, it mentions monoclonal antibody aggregation near silicon oil and water interfaces. So someone as a reader who is reading the title for the first time should get an immediate idea of what your contribution is in the paper. So I have seen that there are some titles which some people write which are very cheesy. For example, there is a very famous paper on transformers, which is "Attention is All You Need," which is path breaking in the field of generative AI. And if you see the title of this paper, it has now become very famous. But at that time, if you would have come across this, it probably looks a bit cheesy, right? It says "Attention is all you need." It doesn't really specify what the paper is trying to convey. So there are these sorts of research articles as well, where the title doesn't really convey anything, but it is simply a hook for the readers into your paper. And this is becoming somewhat of a trend now in some of the papers in the machine learning community as well. So that is the title. After you decide your title, you have to write your abstract. And I used to be always very lazy in writing the abstract because for me it is the least important thing in writing a paper. But what happens is that when reviewers are looking at your paper, sometimes they do not have the patience to read your entire paper line by line. So they will form an initial opinion of your paper based on the abstract. And after that, of course, when it goes out and it is published, the number of citations that you get, they depend on the quality of this abstract, because people who are trying to cite you, they are trying to read your research papers, they are trying to get an idea of what this paper is talking about. And if your abstract is written very shabbily, people will get absolutely no clue what you are trying to say. So for example, let us look at this particular problem. Here we have divided the abstract into 4 main points. And this is called as the hourglass approach. So what the hourglass approach says is that at the top you mention what is the problem, so which is a broader level idea. Then in the second step, you go a little bit narrower. You mention what is the specific challenge which you are trying to solve and how are you addressing these challenges. So point number 2 and point number 3, they are very much related to your own methodology. What is the method you use? What is the parameter you use? What is the novelty? So people who are specific to the field will understand this, and then you again go broad in the fourth step. So if I'm a person who does not have any idea of your field, I can still understand point number 1 and point number 4, even if I don't understand point 2 and 3. If I am an expert in the field, of course, I am understanding all the points. But imagine if you just had point number 2 and point number 3 in your abstract, you're losing out on all this other audience who doesn't understand the technicalities. And this is very nicely explained in this particular abstract. You can see that at the top, the large scale problem is that the researcher is trying to solve the dust accumulation on solar panels is a major challenge, and solar panels typically use large quantities of water to remove the dust. And anyone who is in the field can understand this because the language is so easy. Then if you go to the point number 2 and point number 3, it dives a bit deep into the technicalities. For example, here we are introduced to the technique which this researcher has used, which is mainly electrostatic repulsion due to charge induction assisted by absorbed moisture. People who are new to this field will have absolutely no clue what is happening here. But then when they again move down to step number 4, they are again made to believe that, okay, maybe I'm understanding what is happening in this abstract, because it says we demonstrate dust removal over a broad range of relative humidity, making our approach widely applicable, and we develop a lab scale prototype and demonstrate up to 95% recovery. So it is catering to all types of audiences, and it is making a lot of impact. So in the abstract, it is okay if you say things which are not 100% true, slightly exaggerated. It is perfectly fine because you want to make the maximum impact in your abstract. I have seen that generally researchers are a bit conservative. They tend to be very specific to what they have done. But this is what my advisor also taught me. She taught me the art of writing an abstract where you really pull people in, and not just the technical people, but the broader audience as well. And this is very useful when you are writing the abstract for a conference paper, because in many types of conferences, they just look at your abstract. That is all they even accept. That is all they require for the submission, and then they evaluate your acceptance in the conference just based on the abstract. So then imagine the value which this single or 2 paragraphs carry in the research paper. So now let's move on to the next section, which is the introduction. So in my opinion, introduction has always been one of the most important sections of the research paper, because it gives you a platform to express all the reading that you have done. Imagine that as a researcher, you read 5 articles, 10 articles, but you think, okay, this is not very useful for me, and you realize that at the end of reading the article. So that reading should not go waste. You should mention that in the introduction, saying that these papers did this, but it was not very useful because they found that this method lacked in certain parameters, etc. So every single paper that a researcher reads is useful, and it has to find its way into the introduction. And that is why this was also one of my favorite parts of writing the research paper, because it allowed me to express myself and show to the admission committee that I am not just doing some random analysis, but I have actually done a very thorough analysis of what all people have done in the field and what is my contribution. So here you have to go in a very systematic way. And what is the systematic way here? You have to follow these 5 steps. The first step is, what is the problem? Second, how are people trying to solve this problem? Third step is, what are the issues with the current approaches? Fourth is, what do you propose? And the fifth is large scale implications. Now, the one thing which I was very bad at when I was starting my research is that I used to completely miss out point number 3 and point number 4. I used to write introduction which conveyed nothing. What is the novelty in my paper? Whenever people used to read my introduction, they used to think that, okay, this is already there in the literature. So what is this person contributing? Whenever you're writing a journal paper, you have to focus a lot on the novelty aspect, because you want to write something which people have not done previously in the literature. and then you want to add to that entire repository of research which has happened in that particular field. Now, this is very different when writing a review paper. When you are writing a review paper, you don't have to mention the novelty. For example, let's look at this review paper. In this review paper, they have mentioned that the contribution of this paper is to provide an analysis of the available literature on big data analysis. That's it. And why is this paper accepted? Why is it valuable? Because any new person or a researcher who is coming in this field of big data analytics, instead of reading 50 or 100 papers in this field, I simply have to read one paper which kind of summarizes all the things which have happened. So it's a great entry point for any researcher. I myself consider a lot of review papers very highly because they have helped me introduce to a lot of fields in a short span of time. Now I'll show you an introduction which I have written. So I also generally start from something which is very broad. So here you can see I start by explaining what are therapeutic antibodies and how they are useful in the treatment of various human diseases. And then I dive deep into the problem. This approach imposes an upper limit on the dosage volume, etc. And I make a specific point to mention that what we have done and what is the novelty in this particular paper. So I mentioned that to this end, using computer simulations has proven to be effective. And then it goes into detail saying what all people have done in the literature. So here you can see this particular introduction was extremely long, and I was very proud of this because I had done a lot of research on this, and I had read a lot of papers in this field. And what I have done here, you can see in this line, to the best of our knowledge, computational modeling studies focusing on this particular has not been documented in literature. This is when the people who are reading my introduction get a clear-cut idea of what my novelty is. Otherwise, all of this is not useful. I have written what all people have done in the literature in 3-4 paragraphs, but what is the novelty that you are bringing to the table? You have to mention that very clearly. And then towards the end, you have to mention what is exactly the paper talking about. So here again, we mentioned to the best of our knowledge, this work is the first of its kind numerical study to visualize antibody molecules near interfaces. We use a 24-bead model, etc. So then it dives a bit deeper into the actual methodology which is used to analyze this problem. So I hope you got a better clarity of how should the introduction be structured. So first step, as Raj said, is that you can use Mendeley to document all your research papers, whichever you have read. Remember that none of the research papers really goes waste. You can always cite it in the introduction in some way or the other, and make sure that you introduce the novelty aspect very clearly in your introduction. Okay, so now we'll move to the next point in the paper, which is figures. So if you look at the first paper, which I had started to write, these figures, you can see they look very much blurred. I don't really see exactly what is happening here. Even the y-axis is not labeled. So it's not a very good figure at all. And I've seen that a lot of students who are new to research, they quickly make a graph and then they just upload it. So some of the basic things to take care of is that whether your image is appearing blurred or not. And that is many times not easy, even if it sounds simple. Many of us don't know how to make an image which has complete clarity. So I would highly recommend you to start using either Canva or Adobe Illustrator to make images. Because if you keep using Microsoft PowerPoint or let's say any other software, there is also a software called Inkscape, which I was using briefly for creating images, but then I switched to Canva and Adobe Illustrator. There are some researchers who use Blender to create 3D models of images, and those are also very good, and they add a lot to the quality of the paper. So the first thing to make sure is that your image is not blurred at all. Your image is very clear. It has a lot of clarity. The second thing to make sure is that your x-axis, y-axis, legend, everything is labeled. You don't miss out on any labelings. Once you take care of these two things, right, majority of the things are already taken care of. I would say a lot of students don't take care of these things, but they appear simple, but they are very crucial in forming that first impression. Once that first impression is formed, you have to think of how can I make this figure easily understandable. So you can see this is a figure which appears simple, but it has been made with a lot of thought, because by looking at this simple figure, I can clearly understand there is something in the background, which is the actual antibody shape. And then I have made a model to represent that shape because I have superimposed that on the molecule. So this was an idea which came to me after quite a lot of thought, because initially I thought of just adding this model, but then I was thinking, how do people understand what is my contribution? So then I thought of superimposing it on the actual antibody molecule so that people will see what I'm trying to do exactly. So thinking about the right set of figures generally takes some time, but you have to keep at it. You have to make sure that your figures are present. Now, some of my papers were a bit mathematical. So you can see here, there are less number of figures, but you can see the clarity is very good. Irrespective of how much I zoom, I can clearly see all the labels. And this makes a lot of impact. And this was a particular paper where I think I had only 1 or 2 figures, but then I made sure that they were simple and easy to understand, and they were easy to grasp as well. And this was another paper of mine where similarly I had a simple figure, but I made sure that the labelings were clear, they were not blurred, and the labels were very easy to understand for people and for people to follow. Okay, so the figures should actually tell a story on its own. As you can see here, we have connected figure 1, 2, 3, 4, 5. And the arc of the paper should actually move along with the different type of figures that you have drawn. So what do I mean by this? Let's say there is a reviewer who is doing a review of your paper, and the reviewer doesn't have time to, let's say, go through all the text. So instead, if you have wonderful figures that make a great first impression, from the figures itself, I can understand what is the story which you are trying to tell. So this is an extremely key point which I want all of you to take out of this webinar, is you have to make sure that the figures are telling a story, and you spend a lot of time in making sure that your figures are perfect. And this is one of the main points which I will emphasize when writing a research paper and increasing your chances of acceptance quickly. So yes, so as it is written here, most people won't read your full paper. They will only skim through the figures. So you have to really pay a lot of attention to your figures. Okay, so now let us move to the next step, which is outline of the paper, and this includes the tables. So this was the first advice which the PhD student that I was working with gave me, is that whenever you are writing any introduction which has a lot of things, always include a table. So as you can see, I have made a lot of mistakes here, but I had followed his advice, and let me actually show you. Okay, so this is the table. I hope you can see it. On the right also there were some things, but basically I have divided this table into multiple columns: liquids, walls, contact angle, etc. And every single entry here represents what people have done for these different materials or liquids. Let me see how I can do this. Okay, so then I have tried to implement this for a different paper. So let's look at this paper. So this was a paper which I think got accepted because of the introduction and the way it was written. So I hope all of you can see the introduction section of this paper. And here I have mentioned the name of the work, the problem type, the method, and the distance. And anyone who is reading this is immediately made aware of what is the contribution in our work. So you can see that in no other work, all the problem types are analyzed with this method. So we are analyzing 1, 2, 3, 4. In most of the papers, it's either 1, it's 2, it's 3, 4. In this paper, it is definitely 1, 2, 3, 4, which was published by my professor, but it was in a specific scenario. And plus, we are now solving the problem in a different range altogether and using a different method. So anyone who is not interested to read my entire introduction, they are just looking at this table and okay, they get a first impression. They understand what I'm trying to say. They understand where this work lies in. So sometimes I even think that the main reason why this work got accepted is because I introduced this figure, and this was because my PhD student whom I was working with actually told me way back that you have to include a lot of tables, and I remember that advice while writing this paper. So these small little things will actually increase your chances of your paper getting accepted earlier, of making sure that your quality of paper is increased. And you can add the tables and the figures in overleaf as well. It is fairly easy to do that, and it appears very professional if you add these elements in overleaf. So now we'll go to the next section, which is adding references, and I'll tell you the way which I used to do it. So what I used to do was that, let's say, let me go to an overleaf document, and we'll go to one of the papers which I had written. So let's say we go to this paper over here. Okay, so every overleaf document has this .bib file over here. So what this .bib file does is that it has the references of all the articles which you're citing within the document. So now let's say there is a new document we are reading, let's say this, and we want to cite this document within overleaf. So the method which I used to follow was that I used to click on this cite option at the bottom, cite here. And then I used to click on this BibTeX at the bottom over here. And then as soon as I click on BibTeX, you see it appears like this in this format. Then I used to copy this. I used to head over to overleaf and then paste it at here like this. Okay, so you can see this has been pasted over here. Now what I'll do is I'll go to the main text. And then whenever you cite it, it will directly appear. So for example, let's say dash cite. And then what was the name of this? Nakano, right? Nakano. Okay, so what I'll do is I'll go here, I'll do dash cite NAK. So you can see it has automatically appeared here as a reference. And this is the way you write the references, and the same process I used to follow for all my articles. You can see here it's /cite and then the name of the reference. So this is the way how you add citations and how you refer to articles within your document. And the more references you have in your document, it increases your chances of acceptance, because it lets the reviewers know that you have done a lot of thorough analysis before you're writing the paper. Okay, so now I'll go to the last section, which is bulleted point paper outline. And so once you have written the first version of the title, the abstract, introduction with references, first version of the figures and the tables, then you start to write the first version of your entire document. And this is the acknowledgement section, which always comes towards the end. And then you finally put all these documents together, all these individual entities together in the main body of the paper. And then you go back, then you go ahead and you write the conclusion section of the paper. So as I mentioned previously, the abstract is very important if someone is reading your paper and is deciding whether that particular person wants to cite your paper or not. The same goes with the conclusion also. Generally, when I am reading a paper and I want to skim through the paper fast, what I do is that I go through the abstract, then I go through the introduction briefly, and I directly jump to the conclusion. So the conclusion is one section where you have to keep it very simple and quickly summarize the paper with the key and the actual takeaways. So just to summarize, you have to start your paper with a title and the abstract. Abstract and conclusion are very important, even though you might think that it can be taken lightly. Introduction is one of the crucial sections of the paper where you have to write a summary of what people have done and introduce your novelty. And make sure you include the tables also in the introduction, because it gives a very quick overview of your contribution. Then your figures should be connected such that they tell a very simple story. Okay, so now I'll stop sharing my screen, and Dr. Sridath, will take care of the remaining portion in the paper writing process.
Thanks, Rajat. Hope my screen is visible. So I'll give you a walkthrough through the entire paper, what kind of writing style you can follow once you are finalizing the paper, how to identify an appropriate journal, and what happens after submission. So these are some questions that many students I saw asking in the chat, identifying the journal, impact factor, etc. So we'll cover that in this section. So the entire paper manuscript is basically a collection of the individual sections that Rajat had mentioned. So I'll just show you it section by section. So for one of my papers, my title came out to be 11, 13 words. It had very specific aspects of my work, but also it had general aspects which appeal to general audience. So when somebody reads the title, they should understand what is the paper generally about and what is your specific contribution. The abstract was around 120 words. And then the introduction section had very clearly, distinct paragraphs, each of which talked about what is the problem, what are the ways in which people are trying to solve the problem, what are the shortcomings with the state-of-the-art approaches, what do I propose, what are the merits of my approach, and how does it work, and what are the large-scale implications. So if you look at each paragraph separately in the introduction section, each of these paragraphs talk about one of these ideas. So totally, if there are 5 or 6 of these things which I just mentioned, there will be 5 or 6 paragraphs. Overall, the length of this introduction section will be around 1,100 words. And I split my figures in such a way that in the introduction section, I always have a figure which talks about the problem. And then the next figure will be talking about the solution in a broader way. So my figure 1 was always talking about problem. Figure 2 will talk about what is my approach towards solving this problem. Then figure 3, 4, 5 will describe the science of the solution. So in my specific case, I was talking about how do I estimate the charge, what are the dynamics of a charged particle system resting on a solar panel, etc. And then the very last figure was about how do I build a lab scale prototype by applying all this science which we learned. So that is the style that I follow. So if you really look at the paper, ultimately, if somebody wants to understand this paper, they don't even have to read the whole paper. They can just read the abstract, go through the figures and these figure descriptions, and maybe also read the conclusion. That's it. And I can guarantee you, anyone, if you go through this paper just through the figures, you will understand it to a great extent. And that's because that's the importance that we assign to making the figures during writing a paper, and that can have a huge impact on the way people perceive your paper. I had received reviewer comments saying that the story is incredibly well written and it's so clear. And the same comment I also received from my PhD thesis defense, the committee members, because the storytelling has so much importance when you are communicating with other scientists or other researchers, and they really appreciate if you take all possible effort to convey what you're trying to say in the simplest manner possible. So I deliberately tried not to use any complex jargons, there were some students who were asking the question, not in this webinar, in the previous webinar, should they use complex English words to make their work appear more sophisticated? Absolutely not. Use the simplest possible sentences, make your work understandable to someone, then they will appreciate what you have done. So overall, this is the paper, right? And then you have the discussion section. So discussion or conclusion is what usually you end with. You probably won't have both in the same paper. So in my discussion section, I was just summarizing, but sometimes there will also be a conclusion section. And materials and methods, sometimes if you are not working in a physical experimental lab, you will rather have just methods or like an appendix. Or if you have a code or algorithm, you'll be describing that at the end of the paper. But this section does not have too much weightage, because this is not the make or break section of your paper. The make or break happens in your figures, in the abstract and introduction. The results, whether results are not anyway making or breaking, right? If you don't have great results, you don't have a chance anyway. But if you have decent results, the making or breaking of your paper happens in the storytelling. And basically that's the structure. But one important thing is the supplementary material. So usually when students work on papers, they won't have just 6 figures. Maybe you have 10 figures, 15 figures. And it doesn't make sense to put all the figures in the main body of the paper, because some of the figures are not really adding too much value to the story that you are trying to tell, but yet you want to include them because it has some details which you don't want to omit. So what you can do is you can include them in a separate supplementary section. So this was my paper supplementary section. I had 6 figures in that. I also had a lot of videos. So let's say you have a simulation which is like a GIF or like a MP4 format video. You can add that in the supplementary section. So in this supplementary, I describe some of the equations which I did not want to include in the main paper, because it would make the paper unnecessarily long and complicated. I also did not want to include some figures which I thought I can rather put somewhere else, and that was the supplementary section. So in that sense, supplementary section is like a, I don't know, if you are writing something and you don't want to completely throw it away, but you still want it to be somewhere else, supplementary section is that section. Unfortunately, that's the way it is. But and not many people will go through the supplementary section in detail, but you will get some advantage when you have a very detailed, well articulated supplementary section, because people will see that your work is much more than what they see in the paper, because there is a lot more you want to communicate, and you are trying to give the readers as much as possible through your paper plus your supplementary. So that is about the entire paper. The supplementary can also include your code or description of the movies, like the videos which I mentioned, any other extra figures, any other data, or anything else, any other information that will help the reading. And finally, let's come to the writing style of the paper. This is so important. So I have shared a document with all of you in the chat. If you have missed it, I'll share the link once again. So this document was almost like a Bible that we followed in our research group at MIT. So this is from George M. Whitesides. He's a professor at Harvard, and his group, basically he has written this 3-page article on how to write a scientific paper. So if I recommend all of you to just go through this once. It just basically gives you an idea of how to think about scientific storytelling. And this is so important, because your paper can literally end up getting rejected from everywhere just because you did not focus on your storytelling. And in the writing style, there are a few things that you should take care of. First is the style of writing. There is active style of writing and passive style of writing. So active style is something like passive is like the imaging was performed using SEM. So it's as if somebody performed the imaging in the SEM, right? But that makes it sound like, okay, you are just reporting things that someone else did, but in fact you are the one who did the SEM imaging. So the active style of writing is we perform the imaging using SEM. So in general, of course in the paper you will find both passive and active style of writing. It's not like 100% of the sentences in a paper will be active, but in general active style of writing is more preferred, because it's more as if you are telling the story to the reader. So that is generally more preferred. Passive style of writing, I have seen many students do that, like this was performed using this was performed using that. It's okay in some places, but in general, don't just follow the passive style. It kills the the energy of the paper, mainly because it feels as if you are just reporting. You are not telling a story. You are staying far away from your work and reporting something that's happening far away from you, and that makes it feel like you are not so confident in your work. So don't try to minimize passive style of writing. Another one is past tense versus present tense. So if you are talking about a physical experiment which you did, then you should mention that in the past tense. So the imaging was, so let's say if we take the example of a passive sentence, the imaging was performed using SEM. But let's say you have bunch of images from this SEM, or you have some graph you plot in your paper, and then your paper is like describing some analysis you are doing on, or some conclusions you are drawing from what you see in this graph. Then you write that in a present tense. So more like we analyze the SEM results using image A and find that this. So things which you physically do, or even some simulations which took some time, which you did in the past, you mention in past tense. But things which you are finding out, or things which you are taking the reader through as the reader is going through the paper, you mentioned those things in the present. We observe that particle roughness is greater than 10 microns, and this results in increased van der Waals force of adhesion, whatever, things like that. But if you are mentioning, okay, we performed the experiment in varying humidity conditions, but these experiments were performed under 5% humidity. So in those cases, use past tense. And an absolute no-no is spelling and grammar mistakes. And this is something that in this age of, there are so many tools, just install Grammarly or any other plugin. If you are writing using Overleaf, just install a Grammarly plugin. You can avoid every single grammar or spelling mistakes. I used to have Grammarly Pro subscription, I think, when I was in the university, but now I'm using the free version. So free version has limitations, but if you have a Pro subscription, if you are planning to write papers, that's a very, very good investment, or at least for the temporary purpose. It's very important, because I have seen so many times when students send initial drafts for review, there are like spelling mistakes and grammar mistakes, and I'm like, how do you even make this? Isn't it so obvious? Like, isn't it obvious to you that you should not rely on your human ability to find out spelling mistakes, just rely on some software? So just do this. And after you write the paper, after you go through the Grammarly spell check and everything, and once you think the paper is almost there, you just do one thing: take a printout of all the pages, have a pen or highlighter or whatever, and go through the paper line by line by reading it a bit aloud. And this really works, because when you are reading aloud, if you have a spelling or grammar mistake, when you're reading it aloud, somehow your voice you will catch, and then you will notice these mistakes faster. If you don't read it aloud, you can easily skip through the spelling mistakes in your mind. So you can easily read things fast, and even a mistake or things with mistakes you can read really fast if you are reading in your mind. So at least do this once if you really love your paper, and if you want it to be pitch perfect, and if you really want to treat your paper like your baby, take a printout and go through it line by line, read it yourself, and at least do this once, and that will save you a lot of trouble later. And now let's come to this part where how do we identify the journal? And this is a very big question. If you are almost wrapping up a paper, or if you are even starting to think that, oh, I have done a project and I would like to convert this into a paper, but will there be any journal that will accept my paper? So first of all, you can start thinking about this way. From Google Scholar, you can find similar works to what you are planning to publish. It's very unlikely that you will be doing a completely different work that no one has ever thought of. That's unlikely. So there will definitely be other journals, other papers. Find which journals have published these papers. And then you can categorize the journal based on their impact factor. So impact factor is basically, on an average, let's say a journal has impact factor 10. What it means is, on an average, any paper that is getting published in this journal will get 10 citations throughout its lifetime. So impact factor less than 1 is like kind of low. Anything between 1 to 3 is moderate, and it's something that you can aim if you are an undergraduate or master's student. I think 1 to 3 impact factor is, I would say, within your grasp. Impact factor 3 to 10 is kind of high. It's I would say a bit ambitious. About 10 is very ambitious, especially if you are working without too much resources. If you are working with a very highly reputed professor in a lab who has a history of publishing high impact journals, of course you can aim high impact publications. Anything about 25 or something is exceptional. It's almost impossible to do. So you have to create a Google sheet of this list of journals, impact factor, and another important thing, please note, cost of publishing. So can you, I don't know if you know, so if you want to publish a journal, an article in a journal, you have to pay something called as article processing charge, APC. And for many journals, and this is the basic thing, right? Article processing charge. And then on top of this, if you want to have your paper as open access, meaning if you would like other people to access your paper for free, so that you can get more citations and more visibility, if you want to do that, you have to pay something extra. So if you want to publish, for example, in Nature with open access for others, the article processing charge plus the other fee is $12,000. It's like crazy. It's like 9.5, 10 lakh rupees. So please be aware as a student. This was possible for us at MIT because our project funding covered the cost of publishing in these highly expensive journals. First of all, getting acceptance there is a big deal. But even many other journals whose maybe the APC is not $12,000, they are still high, like $1,000, $2,000. It's still not small, right? So try to identify journals which may have a free publishing option. There are several journals like that for review papers. Also, there are several journals. We'll share the links with you. But try to understand. Otherwise, if you are already in a university, you can ask your department if they will give you some reimbursement for this publication, which many universities have that kind of a provision. So try to find that. And after you submit, what happens is, if you submit to a journal in the first 1 to 2 weeks, there will be like an editorial review. So there will be one or a group of editors quickly going through your paper. They get several dozens of submissions every day. So it's very difficult for them to go through the entire paper. They'll read your cover letter. So you have to write a 1 to 2 page cover letter to the editor. In this cover letter, you can glorify your paper as much as possible, because only editor is seeing that. And then they will let you know if your paper will go into the peer review or not. If it does not go into peer review, it's very, very good. The reason is that means you aim for a paper which is probably out of your league, and you did not waste too much time. You probably wasted only 1 to 2 weeks of time. Someone was asking in the chat how to get paper published in one shot. It's impossible to do. Even MIT professors fail to do that. And in fact, in our lab, we used to discuss this. Like, so if we had like an internal like philosophy that if your paper got accepted in the first attempt, that means you did not try aim high enough, because you don't know how much higher you could have gone. So only when you get a couple of rejects, you will know, okay, this is a domain, maybe I have to come down in terms of impact factor to have a realistic chance of getting this published. So so try for high impact journals initially. It may not work out, but you will not lose any time. If it goes into peer review, it's amazing, because then you have a 50-50 chance of things getting published. So you can try for high impact journals initially. If it does not work out, no issue. Peer review can happen in 4 to 8 weeks. You will get the first round of feedback. It may take longer if some reviewer is not available. The feedback can be crazy. Some reviewers are really crazy. Some of them are stupid. And you don't even know who are they. So that's how the process is, unfortunately, but that's okay. Then the revision, you will have 4 to 6 weeks to revise and make changes to your manuscript if they are inviting revisions. And then when you submit, and if they accept immediately, there will be another 2 to 4 weeks by the time it gets published. So this what I'm showing is like a tight timeline. This is like what 2 months plus 2 plus 1 plus maybe 3 to 4 months of timeline. Usually it takes even longer, 8 months. There was one paper in my lab which I was also part of. It took 2 years to get published. So it can happen, and it's very common. You have to deal with rejection. It's part of being in academia. If you are going for a PhD also, you will experience this. So try to develop thick skin against this. Many reviewers are really unfair in my experience. So some of them are arrogant, stupid. You can't really educate them, and you have to deal with it, right? You have to refute them, but still be respectful when you're rebutting, like when you are making counter arguments to their arguments, right? So all of this you learn how to manage when you submit a paper. And yeah, so that's about paper publication. Now, before we summarize everything, I also want to talk a little bit about long-term mentorship, but we also have a Q&A section where you can continue to ask questions in the chat, and we'll be addressing it one by one in the chat. So someone was asking in the chat, what is LTM? LTM stands for long-term mentorship. This is something that we started since 2022 beginning. So it's almost been 1.5 years now. And the 2024 cohort has already begun. It has mainly 2 ideas. One is to help you build your research profile. Second is to help you tell your story during the application. And in the research profile, we are working with one of the 2 things with candidates, working with a review paper. And if they have like a work that is in an advanced stage, which can be submitted to a preprint with some additional modifications, we can also work on a research article. But it depends on the time constraint. Right now it's June. So June, July, August. So these 3 months we can use for this, but it'll be difficult to do it beyond that. So phase 1, the students who are joining phase 1 in June will have a phase 1. Otherwise, if someone is joining after that, they will not have a phase 1. Like we will not continue phase 1 beyond, I would say, mid of July or something like that. And this is mostly meant for PhD, masters, and research internship applicants like DAD, MyTax, etc. So if any of you are still in the 2nd or 3rd year of college, you're welcome to check this out. Phase 2 is only about the storytelling for the application, where we'll be working on university shortlisting, SOP, LOR, resume, portfolio website. The sixth thing, interesting thing, portfolio website is something that a very small fraction of students have, but it can give you a significant competitive advantage. So Raj had mentioned one of his papers, which was still in the making, in the draft stage. He mentioned it as a publication in the publication section of the resume, and in the bracket provided the link, the hyperlink to the paper draft, which was hosted on his portfolio website. So that's a very, very good thing to do, because in case if there is some advancement, the paper got accepted or something after you apply, then you can just make that modification in the portfolio website. That is option number one. The second one is you can also email the admissions committee saying, hey, there is a significant modification in my profile. Would you allow me to edit my resume, just 2 lines of my resume, because this paper has become published and it might help my chances. And there is a 50-50 chance that they will allow this. One of my friends did this during his MIT applications, and it worked out for him. So, but otherwise, we'll figure out what is the best way to shortlist universities based on your profile and based on what the university has to offer, meaning the work of the professors, its reputation, history of taking students similar to your profile, etc. Of course, having a really compelling story in the SOP, LOR, and resume. GRE, TOEFL, IELTS, we don't have an official program, but we'll share you some free material and some advice based on our experience. But this is not something that we are so passionate about doing. We'll help you on this, but we really don't have a official GRE, TOEFL, IELTS program. GRE is anyway, by the way, not needed for 9 out of 10 universities. TOEFL or IELTS, you will need it, but you can crack it with good score in maybe 2 weeks of preparation. And we have a very nice research profile assessment tool. It's like a Google form with a lot of deep, detailed questions. And we'll be sharing with this with you the first thing when you join for the LTM. The only reason why we decided to continue with LTM this year, even before the admission results came out, was because of the actual tangible other kind of benefits which came out of it, other than admits, which were a lot of papers getting published and getting into the review phase, getting published in preprints, etc. A lot of conferences and in many research areas. So last year we were working with several different candidates from CS, molecular biology, from gender studies, from economics, even from architecture. So many different branches. So that was so fascinating, and we also learned a lot about some of these topics as part of our effort last year. Several of them got into internships at MIT Media Lab, University of Toronto, NTU, etc. And this was so good. And now we have this community of students who are very active and they share resources. One group of students who were part of our Discord, they even separately, they worked on a paper. They were from Pakistan, India, Canada, and another, I think a European country, I forgot. So they wrote a conference paper, 2 conference papers together, and then they presented it actually. So these community thing is also, we'll share the link for you to join if you haven't already. Oh, sorry, I skipped a few slides. These are some sample research papers that last year students wrote with us. It's loading slow because it's a bit high, I think, in size. But basically, some of the students had literally zero experience while starting, and we are so proud of the kind of work that they were able to manage. And sometimes we are very critical in our feedback. Recently, I gave a very harsh feedback to one of the students who submitted some figures for her paper. I felt bad about giving such harsh feedback, but to improve the quality, there is no other way. It's hard to sugarcoat and make things better. So. But basically, the students are so proactive, they implement those changes. The paper as a result ends up becoming better. So some of these papers were from domains in which students had no prior knowledge. So we consider it as a small achievement. Like, of course, they spent the blood and sweat, but ultimately it worked out. So it was so satisfying. But at the end of the day, even the admits were very good. So students got into Johns Hopkins, Cornell, CMU, University of Chicago, and many other universities. Like, we have a big Excel sheet. I should have taken it in my Chrome. I don't have it right now handy, but maybe in the next webinar I can show that. We have a huge Excel sheet with candidates and the multiple number of universities that they got admitted into. Johns Hopkins is my personal favorite because in my opinion it's one of the most difficult to get into universities, especially for students from Indian background. I did not know a single person who went into Johns Hopkins or Duke or Yale personally. From MIT I know a few people, but other than that I did not know anyone. And this year around 5 people got into Johns Hopkins from our LTM cohort. So that was so unbelievable because it's so difficult and unknown, like people getting into Johns Hopkins. Not because its ranking is incredibly high. I don't think it's as high as some of the other universities, but still it's difficult to get into. Duke is another such university which is very, very difficult to get into. So one of our students who got into master's program at Duke, she also got a 40% scholarship. So, and it's very likely that by the time she graduates Duke, she will graduate almost debt free, although she's in a master's program. So that's another amazing thing. And most of the students who got admit, they got multiple admits also. So it was very, very satisfying. And I'll not spend too much time on these slides, but basically, you know, right now you can say pretty much we have students who were part of our cohort last year and last to last year, pretty much in most of the top universities in the US and other parts also. I'll skip these testimonials parts also. It was there, but you know, the bottom line of what we are trying to say is we'll help you with respect to the phase 1 and phase 2. We'll help you identify easy and good problem statements, help you identify what is your story which you can pitch during the application. Our program will teach you how to write papers, how to write your story and pitch it in your SOP, in your website, in your resume, etc. And set a timeline for doing all this, not just for publishing papers, but also for finishing your process of application over the next few months. So that will be that. And ideally, if you're so someone was asking, they have worked on impactful projects. Is that valuable? Are papers more valuable than projects? In my opinion, yes. The main reason is admissions committee will spend 30 seconds, 1 minute on your resume. If they see something like this, bunch of random projects, students from China, US, Europe, you know, top countries, South Korea, all these top countries, their profile might look like this. I'm not saying we are not good. Of course, we are also good. But what I'm saying is you should not compare with your classmates. You should compare with the best of the best students from all over the world. And their profile will usually tend to look like this. And we are hoping through LTM, we can take your resume from looking something like this to something like this. Now Raj will talk about one more thing. Do you want me to stop sharing the screen, or should I continue, Raj?
Yes, Sridhar. I can share my screen.
Okay.
Okay, I hope my screen is visible.
Yeah.
So, okay. Till the last year, we only had the long-term mentorship program, but then we noticed that there are a number of students who are usually interested in machine learning, who want to create a very strong profile in machine learning and use it for their grad school applications. So, especially for that, this year we started the Scientific Machine Learning Bootcamp, which has 3 main purposes: to help students transition to ML, do impactful projects, and publish ML research. So when I was at MIT, I was a mechanical engineer. And then after 2 years, I switched to scientific ML, and that completely changed my life. It helped me get a PhD at MIT, do impactful research, and even get job offers. Not many students know about this field, unfortunately, but it's one of the best fields to learn if you want to publish papers in the field of machine learning. And if you have these papers, it will tremendously boost your grad school application profile. So if you are an engineer right now, and if you're in any of these fields on the screen, or any other field for that matter, mechanical, electrical, chemical, automation, battery engineering, civil, finance, any of these fields, scientific ML actually teaches you how to mix machine learning with one of these fields. So it's very different than traditional ML. In scientific ML, you can keep your one foot in your current field and the other foot in mechanical engineering, in machine learning. And this leads to very impactful projects in machine learning. So remember that scientific ML can be applicable to all engineers who are presently attending this webinar. So here's the bootcamp content. I'll also share the bootcamp link with you on the chat. Everyone can go here and have a look at the bootcamp. The bootcamp is divided into several parts. So initially, the first part is explaining the different aspects of scientific ML. And then the final projects are on research-based projects such as COVID-19 infection modeling using SciML, black hole predictions using SciML, etc. All of these projects you can do and you will add it to your resume. You won't find these projects anywhere on the internet. All other projects such as GitHub projects, Kaggle projects, every other student will have. But these are research-based projects which we do with students. You will not find it anywhere else. So the difference between SciML and ML is that ML is more traditional, like data science, computer vision, NLP. For example, ML does not teach a mechanical engineer how to apply machine learning to their main field. Scientific machine learning combines engineering knowledge with machine learning. So that way, engineers really love this field. It's recently started, it's a modern field. So not many people are doing projects in this field. So if you have projects like this, it will really help you stand out. So in the boot camp, for example, you will see you will be doing projects like this. You will be mixing physics with machine learning. One such project is black hole modeling with machine learning. And then the goal is to not just stop at projects, but to help you publish your first machine learning paper. So up till now, there are about 35 students in the scientific ML bootcamp, and many students have published a paper through this bootcamp by combining their main field of chemical, electrical, mechanical, physics, etc. with machine learning. It's brilliant how much impact this can add to your profile. So when you go to the website which we have just shared on the group, it might have gotten lost in the previous messages. So I'm just sharing it again once. You can go over to this website and see the different plans. So we have a student plan, community plan, researcher plan, and industry professional plan. So that at whatever stage of your career you are in, this will help you. As I said, huge number of people have taken the different plans. Overall, about 100 plus students have taken student plus community, researcher, and industry professional plans. And the feedback has been incredible. We did not expect this much amount of positive feedback once we launched the bootcamp. But I guess since ML is becoming so popular now, people are really wanting to switch to ML, and not just that, to publish a paper in this field. Because everyone has projects, but to have papers, it's very rare. And that really sets your profile apart. So ultimately, the goal of the scientific ML bootcamp is four things: confidently transition to ML from any field, implement real life hands on projects, learn to convert these projects into publications, and finally, you can add these to your CV so that you're ready for grad school. Now, Shridath will explain this slide about the life at MIT.
Yeah, Raj, you can continue sharing. So we are at the end of the webinar, but before concluding, I really want to appreciate all of you for taking the decision, or at least considering the idea of going for grad school into these good universities, because it really transforms your life. You will not just do research at the cutting edge, but you will also make friends who will probably be leaders, or who knows, like when you go to top universities, some of them might even become presidents of some countries in the future, who knows. So you will make some sort of connections that will completely take your life to another level when you attend these programs, and of course you will also become good at science. So really appreciate, I really appreciate all of you for that. Can we go to the next slide? So maybe the next one. Yeah, so this is our email, hello@flyvillage.com. If any of you are interested in SciML Bootcamp or the LTM long-term mentorship, just send us an email with these details. Name your what do you do currently, what are you planning to do, what makes you interested in this program, whether SciML or LTM, and just attach your current version of the resume, which will help us understand what's your profile, and if you have any questions, we can give you suggestions based on how your profile looks like. So just reach us out through this. We are unfortunately at the end of our time, but I think we can take maybe a couple of questions from the chat before we wrap up today's webinar. We will, don't worry if you have missed a few things, or if some of your questions went unanswered. It's very common, mainly because of the size of the call. We are conducting like one webinar every 2 to 2.5 weeks. So we will have our next webinar sometime end of this month. You can join that. It'll be on a different topic, of course, but we will still touch upon some topics related to what we covered in this webinar as well. So you can join in that. But before that, if you have any question with respect to the topics we covered today, we'll be taking a couple of questions from the chat before we wrap up the webinar. Yeah, recording. Yeah.
You can go ahead with it.
Yeah. So recording is we are recording. We haven't decided how to share the link, but we'll. Okay, plagiarism and use of AI tools. Someone had asked this question, like, so they were writing a paper and Turnitin was showing a high plagiarism index. So I personally never used Turnitin, mainly because all of my papers I wrote myself, like by hand. I never used any tool. So I never bothered to check whether my paper had high Turnitin index or not, because I wrote it myself and I don't care what a software is telling about my paper. So I never checked it. But if your institute, I know some universities ask the student to submit their plagiarism index report or something before they submit their paper. So Turnitin is the most commonly used. Any other software, guys, like that you're familiar with other than Turnitin?
Yeah, it's a bit difficult, I have found, to find plagiarism tools which are reliable. Turnitin is the only one which I am also aware of.
Yeah, Quillbot also has that paraphrasing, and I think it also has its premium version has this plagiarism checker, I think.
Yeah.
Yeah, AI. I don't know if something can capture whether AI has written something. I mean, we are in fact working on a research project in exact topic, like how to build a tool that can identify AI versus not AI. But yeah, maybe we can take one last question.
Yeah, there are a number of questions I've seen before which mention about the authorship order. So one thing I would like to mention is that the first author carries a huge amount of weightage compared to the middle authors. So if there is a paper with 6 authors, if you are the first author, I would say that is 5 to 10 times more impactful than, let's say, if you are the second, third, or fourth author. And the main reason is there is no distinction between the middle authors. It's very difficult to know the exact contributions which you have made. But if you are the first author, it's usually the person who has written the paper, or who has conceived of the idea, or who has done most of the work. So in my experience, the first name and the last name, which is usually the professor's name, that carries the most importance. So please keep in mind that if you have 5 publications where you are the middle author, whereas if you just offset it by one publication, which is the first author, that will carry a lot of weight. I only had one publication when I applied for MIT, but I was the first author, and that got me admitted to MIT as well as Stanford. Okay, I think it's almost 5 minutes past the time. So
yeah, any other questions, guys? If unanswered, you can send us an email. If it's not an extremely long question, we can get back. Otherwise, we'll have to figure out another way or another webinar. But anyways, thank you all for.
when you send that email,
okay.
yeah. When you send that email, guys, follow the format. Don't just send one line email. So mention your name, email address, affiliation, all the things which was shown in the last slide of the PPT.
Yeah, I'm just sharing the screenshot here just in case in the chat. So
Yeah.
that's the template. So just follow that. But otherwise, thank you so much. Thank you for staying late after the webinar. We'll see again in the next one. We share about our webinar details on our LinkedIn primarily. So if you are not connected with us, just send us a connection request. Any other details that we have missed to share, we'll share with you in your email. Thank you so much, and good luck for your preparations.
Thank you, everyone. Good luck.
Thank you so much, everyone.
Yes. Good luck, and don't feel stressed out. Take care of your mental health. It's very important. Only 5 months are remaining. Don't panic or get too stressed. See you, everyone, in the next session.
Thank you. Bye-bye.